So this is your last section before your quiz. You don't have a quiz this week. You will have a quiz when you get back, though. So relax. When you get back, the first day back, you'll have a review. And then the second day, you'll have your quiz. Okay? So review and then quiz when you get back. Tomorrow we're doing stuff with constructions. And if you're not here, you don't have to make it up. It's fine. But if you are here, you will have to do it. But tomorrow. So today I want to go over inequalities in one triangle. So to create the appearance of depth in a room, interior designers use a technique called triangulation. A basic example of this technique is the placement of an end table on each side of a sofa with a painting over the sofa. The measures of the base angles of the triangle should be less than the measure of the other angle. Okay, so it's just talking about where to place furniture here with your picture, creating that triangle. Okay, so today what we're going to do is use our exterior angle theorem that we talked about in chapter 4. Okay, so by the exterior angle theorem, the measure of angle 1 over here in this triangle is equal to the measure of angle 2 plus the measure of angle 3. Okay, again, we talked about that in chapter 4. I can add in my two remote interior angles together to get that exterior. Okay, meaning that the measure of angle 1 has to be greater than angle 2, right?
Yeah.
Since to get 1, I have to add those two together. And angle 1 has to be greater than 3. Since, again, I have to add 3 and 2 together to get 1. Okay? So that's what we're going to talk about today is the exterior angle inequality. Okay? Inequalities have these less than or greater than symbols in them. So what that says is the measure of an exterior angle is greater than the measure of either remote interior angle. Okay, so your exterior has to be greater than the remote interior. It's not talking about the angle that is right next to it. Okay, even though it may look smaller, okay, or greater, we're not talking about the angles next to. Okay, so when it asks for angles that are greater than angle 3, okay, all you can say is angle 1 since it's at exterior. Okay? So we're going to go over some examples at the bottom here. So we want to list all the angles of triangle EFG with measures that are less than angle 1. Okay, so angle 1 here is the exterior angle. Whenever it says less than, okay, it says less than, you need to think about that angle as an exterior angle to another triangle. Okay, so angle 1 is right here. My angles that are less than that would be my remote interior angles, since I have to add them together to get the exterior. So in that case, I'd say the measure of angle 3 is less than angle 1, and the measure of angle 4 is less than angle 1. Okay, because in order to get angle 1 again, I'd have to add those two together, so they must be less than it. Okay, questions on that first one? That's all the front page is about. Okay, we're going to look at the next section here. Cross this off. Don't worry about that. We're just using this triangle for 2, 3, and 4, not 3 to 8. Okay, so number 2 here, we're looking for angle measures that are less than angle 1. Okay? So again, when it says less than, you need to think of angle 1 as an exterior angle. Okay, so angle 1 is right here. So I want to look for the remote interior angles to that exterior angle. What are the remote interior angles? 5 and 6. Okay, so I would say the measure of angle 5. And the measure of angle 6. You cannot say angle 4. Yes, it looks smaller, but that you can't apply this theorem to an angle next to it. You have to apply it to the remote interior angles, so the angles across from. Does that make sense?
Mm-hmm.
Okay, number 3, we're looking for measures greater than angle 1 now. When it says greater than, you need to think of that angle as a remote interior and look for the exterior angle then. Okay, so if angle 1 is a remote interior, which angle would be your exterior? 7. So I know angle 7 has to be greater than 1. Because in order to get 7, I'd have to add 1 and 3 together. Okay? That's the only one that you can use for that. Okay, then number 4, we're looking for measures less than angle 7. So now again, if it says less than, you think of that as the exterior angle. So I'm looking for remote interior angles. So I'm going to first look at this triangle TWU. Which ones are my remote interiors to angle 7? 1 and 3. Okay, so that was for this triangle TUW. Now I can also look at triangle TUV. What are my remote interior angles to that entire triangle there? 5 and 6, right? Because to get 7, I'd have to add up all of angle U, so that means 3 and 5, and angle 6 in order to get 7. So I know angle 5 and angle 6 would also have to be less than 7, because I'd have to add those to get that exterior. Okay, and again, I cannot say 2. Okay, it's not a remote interior angle to that exterior. Okay, it's the angle next to. Can't use the angle next to it. Questions? All right, I want you guys to do 5 and 6 with that triangle there. You can talk to each other, it's okay.
How many is there for 6?
There's 2 for 6 and there's 4 for 5. How many is there? 4 in number 5 and 2 in number 6. All right, I'm going to start to go over it. Since when I walked around, most people had it done anyways. So number 5, you're looking for angles less than angle 7. So again, if it says less than, you want to think of angle 7 as the exterior angle. So 7 is right here. So I want to look for remote interior angles that would add together to be angle 7. Well, if I look at triangle KML, okay, so this first triangle here, I could say 5 and 4 together would get 7. So I know those angles have to be less than 7. Okay. Then I can look at the larger triangle LJK and look for my remote interiors there. So angle J here and angle K right here, I'd have to add those together to get 7. So that means angle 1 and angle 2 would also have to be less than angle 7. Okay, questions on number 5? Do we do pretty okay with that one? Okay, then number 6, we're looking for angles greater than angle 6. Okay, so again, we want to look where 6 is a remote interior angle then. So we're looking for exteriors. So I'm going to, again, look at this smaller triangle first, since angle 6 is part of that smaller triangle. So if I add together 4 and 6, what angle would that give me? Those are my remote interiors. What's your exterior? Not 7? 3. Okay, so 6 has to be less than angle 3. So angle 3 is greater than 6, since that would be an exterior. There's one more. This time again, I'm going to look at the largest triangle there. So LJK. And I want 6 to be a remote interior. So if I add 6 and 1 together, which angle would I get? 8. So 8 has to be greater than 6. Okay, so that's kind of the process you should work through in your brain. Okay, if this is a remote interior, which one would be added to it to make that greater angle? Questions on these types of problems here? These are the ones that most people struggle with on this section. Okay, then on the back, this one's way easier. If you thought the last one was easy, this is way easier. So we're going to go over angle-side relationships. So when the sides of triangles are not congruent, okay, we don't have congruent sides, we don't have congruent angles, there's a relationship between the sides and angles of triangles. So the longest side will be opposite the largest angle. And the shortest side will be opposite the smallest angle. Okay, so we can list our angles and sides in order from least to greatest. And in example 1 here, we're looking at the angles. Okay, so we want the angles order from least to greatest. So I'm going to first pick out the shortest side. Well, that shortest side, according to the measures, is SR. Well, that shortest side has to be opposite your smallest angle. Okay, so I'm going to go across. My smallest angle is then angle T. And then it's angle R, because that's opposite the next smallest side. And lastly, it will be angle S. Since 9 is my longest side there, angle S has to be my... Where? Okay, angle S has to be my largest angle then. Make sense? Okay, then in example 2, we want to now list the sides in order from shortest to longest. So shortest side is opposite your smallest angle. My smallest angle is A, since it's 20 degrees. So I want to go to the opposite side. So CB will be my shortest side. Then my next smallest angle here is 35. Go to your opposite side. That side is AB. And then your last side, angle B is the largest at 125. So your longest side is opposite that, and that would be AC. Not so bad, right? Pretty good. Any questions? All right, I want you guys to do 1, 2, and 3. So you're listing the angles and the sides from shortest or smallest to largest.
What's 54?
All right, I'm going to start going over these. So first one here, listing your angles. Side RS is the shortest side here. So the angle opposite that is angle T. Then TS is the next shortest. So then we have angle R. And then angle S would be last. Then listing my sides, again, RS was the shortest. And then ST. And then TR. And yes, you could flip-flop these letters and say TS instead. Here, for your angles, you need to find what angle R is. Okay, so to do that, since all three angles have to add to 180, since they're in a triangle, just subtract your two angles you know from 180. So angle R would be 66. So my smallest angle then is angle T, then angle S, then angle R. Okay, then listing my sides. Side opposite my shortest or smallest angle would be SR. My next shortest side is opposite 60, that's RT. Then my longest side is opposite angle R, that's ST. Okay, for number 3 then, again we have to do that same process, subtract our two angles we know from 180 to get angle Y. Again, that's 66. Okay, then my smallest angle here would be angle X. Then angle Z. And lastly, angle Y. Then my sides opposite my shortest angle here would be side YZ. Next, smallest angle is 58 here. Opposite side to that is XY. Then opposite angle Y would be XZ. Okay, any questions on those 3 problems there? Okay, then one more problem. It is a writing problem. Why is the hypotenuse always the longest side of the triangle? I want you to write out a sentence or 2 explaining why the hypotenuse would be the longest side of that triangle, of a right triangle. You can talk to each other if you need to. All right, anybody tell me why is the hypotenuse the longest side?
It is the longest side because it's opposite from the largest angle.
It's opposite from the largest angle, which is? How big is that angle?
Huh?
How big is that angle? 90. Okay, so yes, the hypotenuse is the longest side of a right triangle. Okay, so what I have is, since the hypotenuse is across from the right angle, both other angles in a right triangle are acute. The hypotenuse is always the longest side and is always opposite the largest angle. Okay, so it's pretty much what Sadie said, except I added in that the other two angles of a right triangle have to be acute. Okay, since they're acute and not greater than a right angle, that hypotenuse is always opposite the largest angle in that triangle. Okay, does that make sense?